Welcome, ladies and gentlemen, to Integrated Math 2. In today's episode, we will be discussing Chapter 2.2.1, which is dilations. And so before we begin what we are learning, I do want to give you guys the definition. A dilation is known as a change, and I even copied this out of somewhere, a change that enlarges, or reduces a figure while maintaining its shape. So go ahead and hit the pause button, write that down in your notes. I'll show you guys exactly what a dilation looks like on my Word document here. We've got this image right here that we are going to enlarge or shrink in. Now notice how everything about the Vault Boy stays the same, right? There's nothing I can do. He's not going to become unproportional at this point. His proportions all stay intact. Now, if I suddenly do this and make him taller than he was before, but still maintaining the same width, this is not considered a dilation. Remember, dilations need to preserve the original shape and just expand proportionally. So just keep that in mind. I'm sorry, I flipped him on accident. But that is what a dilation is as a visual thing. And we're back to this page here. This problem here largely revolves around 2-47. What I'm going to do is I'm going to go and list off the points that we have in question here. A, B, C, and D. And what I'm going to do is I'm actually not going to identify their coordinates, but what I'm going to do is I'm going to go ahead and calculate something about how we got there. Now, in class, you would regularly be using rubber bands for this with notches on them so that you could make the figure 2 times, 3 times, 4, or even 5 times larger. But since we're online, I'm not going to be able to do rubber bands for you guys. So what I'm going to do instead is I'm going to give you guys what this problem is trying to teach you with the rubber bands. And basically what it looks like is if this problem is asking me to, and it is asking me to enlarge this figure ABCD about the origin, right? The origin's at the center. What I'm going to do from the origin is I'm going to go ahead and count my slope to get to A. So my slope to get to A will be up 1, 2 to the right by 1, 2, 3. I'm going to go and write that down. My slope is 2/3. To get to B, I'm going to go and say up 2 to the left by 1. So that looks like it's a slope of, okay, so here's what I do. I'm actually going to call him 2/1, but I'll go ahead and call him left. Ordinarily, it would be -2, right? Because we go down 2 to the right by 1. But remember, I'm expanding this from the origin. So I probably want to look at everything from the origin's perspective. So to get to C, I'm going to go down 1, 2 to the left 1, 2. So that's going to be down 2 to the left 2. So I'll go and actually write that down here. Down left. That way I don't forget and think that it's up 2 and to the right by 2. To get to point D, it's going to be down 2 to the right by 1. So 2 down and then 1 right. Okay, so if we looked at these as individual slopes, if I wanted to make the figure, let's say using a 2 rubber band, what I would do is I would actually expand the rubber band out and I would just start drawing the figures. Again, we don't have the rubber bands online, but that's okay. What I'm going to do is I'm going to go and use this idea for slope. That x2 means times 2. Well, what happens when I double a slope? Well, everything grows in proportion, right? For example, I don't go up by 2 anymore from the origin. I'm going to go up by 4 from the origin. I don't go to the right by 3 from my position. I go to the right by 6. And so again, what does that let me see? It lets me see up 1, 2, 3, 4 to the right by 1, 2, 3, 4, 5, 6. I'll go and call him A prime because he's the first, what we call derivative of A. In other words, he's the first thing that A kind of, pooped out. This up 2 to the left by 1 is now going to be up 4 to the left by 2. I'll go and just put an L right there. That way I know. Again, from the origin, up 1, 2, 3, 4 to the left by 1, 2. Again, I'll go and call this B prime. Down 4 to the right, to the left by 4. So down 1, 2, 3, 4 to the left by 1, 2, 3, 4. That's going to be my C prime. And then down 2 to the right by 1, that's going to turn into 4/2. So down 1, 2, 3, 4 to the right by 1, 2. And that's going to be D prime. So from here, if I connect these red dots together, you should see, and I am graphing it somewhat accurately because I have the shift button here, which is getting me really straight lines. Notice how A prime, B prime, C prime, D prime is actually a dilated version of the original. In fact, it's 2 times larger from the center. And so notice how if I wanted to double the figure, I doubled the slope. I think you guys can I think you guys might be able to figure this part. I'm thinking you guys are going to be able to figure this next part out here. If I want to do this thing times 3, I would go back to my original and multiply everything by 3. So 6 over 9. Let's see, again by 3, 6 over 3. 6 over 6, and then 6 over 3. And this figure would look 3 times larger. So up 1, 2, 3, 4, 5, 6 to the right by 9. So that's going to be right here. That's going to, I'll call that, whoops, not C. I'll call him a double prime. He's the second derivative or second pooped out thing. So from here up 1, 2, 3, 4, 5, 6 to the right, left by 1, 2, 3. That'll be B double prime. And when we're all connected, it should look like a larger version. So down 6, 1, 2, 3, 4, 5, 6, all the way to the left by 6, that's 5, so right here. And then down 6 to the right by 1, 2, 3. And there you have it. I think I might have made a mistake with B. Let me see here. So that's going to be up 6. Oh, I see. I'm up 7 on accident. My mistake. Oh, that didn't help. That's okay. Boom, 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 and then boom. So you see how they're all almost like zoomed in versions of each other? So that would be diagram 1. So the biggest point of this lesson is that we expand and shrink figures on the coordinate plane based on the slope from the point of dilation. Let's go and get that in our notes here. We expand, we dilate our figures based on the point of dilation. Whoops, point of dilation. So what you're going to see in this next example is that the point of dilation is actually off axis. I'll be right back with that one. And we are back with the second figure here. So now that we know that we're going to dilate this thing across the point D, let's keep this definition in mind here. We dilate the figures based on the point of dilation. So what I'm going to do is I'm going to go ahead and calculate the slope. I'll go and calculate the slope of each point from that point D, the point of dilation, and then what I'll do is I'll just proportionally expand each slope. So if I go from point D, if I go up 2 to the right by 1, 2, so again, I'm just going to call this 2 over 2, right? 2 over 2 from the point of dilation, and I know that's not going from the origin, but that's okay, it doesn't matter. It is kind of the origin since I'm dilating from that point. So from D, I'm going to go up 1, 2, 3 to the right by 1, 2, 3, 4, 5, 6, 7, 8, 9. That's going to be up 3 to the right by 9. Notice how I'm not reducing my slopes right here. It's very important that you don't. That way you can have a proportional expansion from the point of dilation here. So G is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the right. So 0 rise, 10 to the right. And so if I was to do, let's say, a times 2 on this dilation here. Let's go ahead and change colors here. I'll go ahead and change to sky blue again. So that would make this, from the point of origin here, that would make this 4 over 4. And then from here, point H would be, again, it would be 6 over 18. And then point G would be 0 over 20. So again, I would just use from the point of dilation and go up 4 to the right by 4, up 6 to the right by 18, and up 0, and then to the right by 20. So I'm going to go up 1, 2, 3, 4, to the right by 1, 2, 3, 4. And that's my F prime point right there. H is going to be up 1, 2, 3, 4, 5, 6. Now that's going to be 18 spaces from this point 4 right here. So I'm going to go and draw a quick little temporary X right there. I'll go and call this point 4. So a quick way to do this is if I'm at 0.4 and I'm going 18 spaces to the right, that places me at 0.22. So that's 20, 21, 22 right here. That's going to be H prime. And then G is going to be 20 spaces to the right of the point of dilation. So I'm going to go all the way over here to 24 and call him G prime. And it might be a little hard to see. Maybe I'll darken it. Dark blue, and dark blue. Again, G prime, H prime, and F prime. So let's go ahead and bust that guy in there. And absolutely, he definitely looks like he's twice the size based on the point of dilation. So why don't you guys go ahead and take a second and pause if you want to, and see if you can figure out the ×3 version of this thing. Go ahead and take a minute and pause, but I'll be back to help you guys out. At this point, if you paused and done it already, you might be ahead of me. No problem here. Of course, 6 over 6, 9 over 27, and then 0 over 30 if we tripled our points right here. So I'll go and do this in orange. So from the point of dilation, up 6 to the right by 6. So that's going to be from here 1, 2, 3, 4, 5, 6. Again, oops, did I count that right? 1, 2, 3, 4, 5, 6. I did. So now from here, 0.6, I'm going to go to the right by 6. So 1, 2, 3, 4, 5, 6. So that's going to be point F double prime. This is going to be my first point of my 3x figure here. Up 9 to the right by 27. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll go and just put a little orange X right there. Again, I'm at the X coordinate 4. If I add 27 to him, that will put me at 0.31. So here's 30. Here is 31. So I'm going to call him H prime. And then from my point of dilation, my G double prime point will be, oops, I did double prime. My G double prime point will be 30 points away from this 0.4 here. So all the way over here at 34. And that will be G double prime. And actually, it does. It kind of looks like triple the size. And if you kind of look at it kind of weirdly, it looks like there's almost like this expansion of it. I'm going to darken it in red right here. That way it stands out a little bit more, hopefully. And that is pretty much the lesson. It's a lesson in dilation. The biggest thing, the biggest takeaway from this lesson is the notion that when you dilate a figure, you are enlarging or reducing the figure while maintaining its shape. This will play a huge role in the similarity lesson, which is right after this, and I will see you there. As always, leave comments and questions in the comments area, and I will see you in the next episode.